Right, the projectile is fired straight up with a velocity of 64 feet per second. Its altitude height h after t seconds is given by h of t equals minus 16t squared plus 64t. When will the projectile's height be half of its maximum height? So we present a solution to this problem in a step-by-step manner, but we understand that its altitude height after t seconds is given by this, and we're interested in knowing when will the projectile's height be half of its maximum height. So first, we're dealing with the maximum height. And we note first that the height is actually equal to minus 16 t squared plus 64t. The velocity. The velocity is dh dt, which is minus 32t plus 64, which is equal to 0 at max height. So which means, therefore, t is minus 64 over minus 32, which equals 2. Maximum height. So you actually have that h of t is minus 16t squared plus 64t. So t equals to 2 seconds. So which means at this point, h of 2 is minus 16 into 2 squared plus 64 into 2, which equals 64. Okay, so it is 64 feet. That is the maximum height. So if you look at this question where they say this projectile is fired straight up with a velocity of 64 feet per second, that is the initial velocity. Its altitude height after t seconds is given by this. When will the projectile's height be half of its maximum height? So we're looking for when will the projectile's height be half of its maximum height. So there's a point where, because we know that the maximum height is 64 feet, but now we are interested in half of 64 feet. And now we're then saying half of the maximum height. And when will the projectile's height be half of its maximum height? So half of the maximum height is the projectile's height plus 64t. 32, which is minus 16t squared plus 64t, which means, what do we have here? We have 16t squared minus 64t plus 32 equals 0. Divide by 16 and you have t squared minus 4t plus 2, which equals 0. And t equals minus b plus or minus the square root of b squared minus 4ac out of 2a. Which means it is 4 plus or minus the square root of minus 4 squared minus 4ac all over 2a. And at this point, what do we have here? What do we have here? Right, what we have here is that this implies that we have exactly t equals Right, we have t equals 4 plus or minus the square root, like this, okay, of minus 4 squared minus 4 into 1 times 2, like this, and you divide everything by 2 into 1. And therefore, the answer to this is 4 plus or minus the square root of 8, like this. And you divide everything by 2. And this is 4 plus or minus the square root of 8 is 2, the square root of 2. And you divide by 2. If you divide by 2, then it's 2 plus or minus the square root of 2, like this. And then it means that t is plus the square root of 2, or t is 2 minus the square root of 2. Right, and this is the time here. So we understand, therefore, that t equals 2 plus the square root of 2, or t equals 2 minus the square root of 2 seconds, like this. And therefore, also this one here is in seconds. Right, so what do we have here? So it's these seconds and this is that seconds. So this is actually the time, right? So if it is exactly 2 plus the square root of 2 seconds, and the other one is right, so it's in seconds here, like this. Okay, and then this is approximately what? So here it is approximately 3.41421 seconds, like this. All right, and t is approximately 0.58578 seconds, like this. Okay, so this is what we have. Now, we need to have the understanding that at this point, when this projectile will take is fired straight up, and we understand that it is a projectile which is come back again straight down. Now, the path traced by this is called the uh, trajectory, in which case, therefore, you will have the following. So, which means, therefore, at this point, what do we have? You have t, which equals what? Which equals now on its way up and then on its way down. So in other words, we are looking at what the question is actually asking us here, because at the time that is projected up and then down, there are a couple of things that remain extremely important. We are asking the question here to say, when will the projectile's height be half of its maximum height? Okay, so we're able to determine when will the projectile's height be half of its maximum height. So it will be at these 2 times here, right? So you have the time here 2 minus the square root of 2, which means t is approximately here 0.58 seconds. 58578 seconds. Right, so and this will be sort of the thing. Okay, so you need to just note that. So 58578. T equals 2 plus the square root of 2. 3.41421 seconds. Okay, so which means that on its way up, and then on its way down, would have that the projectile's height will be half of the maximum height. Okay, so thanks everybody for your time and attention, and goodbye to you.